In today's Overland workshop, we're going to talk about suspensions and specifically the maintenance of suspensions. And why this is a very good time for me to do it is that I have a clunk in my suspension that needs sorting. I'm Andrew St Pierre White. Join me as I share my passion for building four-wheel drive trucks and then travelling to the remotest parts of the world. And it's a bit premature, 34,000 kilometres on the clock, but I have done two pretty hard trips on it, and I thought, well, I have to have it checked out. But what a great opportunity to take you with me to the guys that fitted it in Wangara and get some insight into the maintenance of our suspension systems. This is James from my local ARB store. They fitted the suspension and has offered to take a look at it for me.
So we got these little pads between each leaf.
Yeah.
Top one's gone.
Don't most springs not even have pads?
Yes, correct. Yeah. The reason we put that in is it allows the leaf to last a lot longer over conditions like what you're using your vehicle for.
Yeah.
So it stops that metal on metal contact.
Yeah.
They are designed to wear out.
Yeah.
And they're quick and easy to replace.
Okay. Well, I know they give the spring more flex.
Yes.
Makes it easier to flex, so which is why they've got such a nice ride.
So what I'm looking for is unusual wear, or the shackle sitting on a slight angle, or the spacing to be unusual. These wear pads through here between the leaves.
Yeah, between the leaves, yeah.
So the interleaf liners.
Right.
What happens, because when you're articulating the vehicle, the spring is going to naturally move side to side.
Yes.
And what happens is when you get sand and mud and gunk in there, it will act as sandpaper. It'll rub together. And over time, these will wear out, so they're a serviceable part. Some of the brands don't have this included. They'll either just have a rubber pad glued to the spring itself, or a piece of plastic in between, literally just wedged in there, and they can fall out. But ARB have included these. So they actually clip into the spring itself, on the other side obviously. They've got a hole through the middle, so you can pass grease through it. Make service, like
so you can pass grease through it?
Yes.
So my question is, should I have been passing grease through it? Because all I've been doing are the greasable shackles. I've been doing nothing else.
Yes. But it is a serviceable item.
Okay.
So if you're doing lots of water crossings, lots of river stuff, mud, quite dusty environments. Yeah. So it always pays to check. Too much grease in here isn't a good thing either,
because it would just turn to sandpaper. I mean, it would just grinding paste.
Yep. So it will attract all the dust and grime and dirt into this. Yeah. And it'll make it worse. Yeah. So it's a fine line between just enough and too much. Essentially, we're running just a smear of grease across the top of here, filling these little voids to act as a slight little buffer to allow the polyurethane or the plastic to rub against the metal surface instead of having metal on metal or sand on metal. That noise
could be.
So to service these, it's quite simple. Lift the car off the ground, so you get the wheels off the ground, so there's no pressure on the leaf spring itself. Yeah. And then we can pry each of these leaf packs apart. Okay. Pull them out. Yeah. If we need to. Yeah. Or because there's no pressure on the leaf, we can just pry this open a little bit. Get a grease gun. Push this in here because of the hole. It will spread out. Push back down. You're done. My question is now, diagnostics-wise, when do I know that I need to do that? If I'm hearing a noise, or I mean, obviously, if I see one's missing, then I'm going to sort it out. But what else is there? So you'll get either a clunking noise, like you've got. Yeah. You'll hear like a scraping or a grinding noise, especially when doing quite slow articulation work. So when the car's rocking side to side or undulating forward and back, the leaf springs are going to do their work, so they don't travel in just a up and down motion. They will twist. I've seen that. I've got videotape, and it's so clear that they do a lot of lateral movement as well. Yes. Yeah. Which is where you'll get most of your wear through your shackle bushes and your front eye bush. Right. But because we have that side to side and undulating motions of the leaf spring itself, you'll hear extra noise. So leaf springs are traditionally a noisy spring, not like a coil spring, which is in pretty much all the new cars. Having a leaf spring, and because it's so mechanical in the way it works, having multiple leaf packs sliding over the top of each other, you're always going to have noise.
And do you think I've got a problem with one of my front bushes? You mentioned on the front of the leading edge of the leaf.
Yes. If you have a look through here.
Yeah, I can see it.
Yeah. The one above that is completely gone.
It's gone.
And then with our leaves, our second leaf, so not primary leaf, the secondary, has what we call a military wrap. So that...
Which is that wrap there, the secondary wrap.
Which is the secondary wrap. So what that does, if your primary leaf snaps or is fatigued, and it does end up cracking or snapping off, or you snap an eyelet off, which can happen if you're overloaded. In your case, that won't happen because we've chosen the right spring for the job. What will happen is once that primary leaf goes, or it's snapped or it's broken, you've got no way of getting home without the military wrap. So the military wrap is on your secondary leaf, so primary, secondary.
Yeah.
What that will do is it will hold your leaf spring together, and it will allow you to limp back home or back to the nearest town or workshop where you can get another replacement leaf. A lot of other springs don't have that. It's a very old technology. It was used back in the military, back in I think World War II, I think, with the original Willys Jeeps. I'm pretty sure, don't quote me on that, but I'm pretty sure that's where it came from.
Okay. That's what came out, yeah?
Yeah. And because it's the leading edge of the spring, it's always going to get blasted by sand and stones and everything that's getting thrown up by the front wheel.
That's what came out, yeah?
Yeah. The leaves themselves, they're in pretty good shape. A little bit of surface rust, but that's common. These ones here, what happens is the grease will dry out over time. If you can see that.
That's uneven wear. It's wearing more on the trailing edge than the leading edge.
Yes. And that's typical because the leaf isn't completely square.
Yeah, it's not flat.
It's not going to be.
Yeah.
It's not like blocking like a panel. It's it's going to be wearing on a curve.
You've got a curve. You've got more pressure there than you have there.
Yeah, exactly right. Yeah.
James went on to explain that not all greases are the same.
So if we're comparing the two, the moly grease has molybdenum. I can't even say the word. It's got a.
Say it slowly.
I'm going to say moly. It's got a moly base into this. It's extremely slippery. You can get a pressure washer onto this and it will disappear. You get a pressure washer onto the extreme pressure, it lasts a lot longer. This is good for enclosed situations like uni joints, CV joints, things like that. Protected items. Right. Whereas this we can put onto the outside. And it will
so you would use that for a wheel bearing or a CV joint?
I would use this in gift locker situations, so rebuilding gifts, CV joints, universal joints, things like that.
Yeah.
It's much better at lubricating at a higher temperature. So this will have a high shot load in our situation. So
because it's a pressure grease.
Yes.
Yeah.
This is still a pressure grease, don't get me wrong.
Yeah. Yeah. Well,
if I was going to choose one,
anything with EP is extreme pressure.
Yeah.
So servicing greasable shackles, pumping in grease, I never know when to stop. I mean, it comes out, it oozes out from all over the place, but when do you actually know when the entire bush has been lubricated with new grease and it's pushed out the old grease?
So when you pump grease through there, it's going to come through these holes either side, and it's going to lubricate the centre spline. This is not the right bush for this, but it's the first thing I grabbed. So inside here, there's a little groove. When we push grease through this grease nipple, it's going to fill this entire greasable pin up with grease.
It's going to come out of those holes, yeah?
It's then going to find its way through a path. In our bushes there's a groove inside here to hold grease. It's going to lubricate this whole surface. So when you grease, it's not necessarily going to come out evenly. It's not going to come out this side and that side.
Okay.
It's going to essentially put pressure through here, and like anything liquid, it's going to find its easiest path and escape. So when you do it, it's going to come out of this joint here, it's going to come out of here. When I greased this up just then, I didn't get any pressure out of this side. But I know that there's enough pressure being built up through the grease gun, through here, to fill up all the voids, and then have enough grease to push it out. U-bolts.
Yes.
If your U-bolts, over time, they will stretch.
Yes.
You've got to check them. If you don't check them, what will happen is your leaf pack will essentially spread apart, and you'll get more movement. You'll get, when you're off-road, doing the undulations, it will move more. You'll get clunking, you'll get scraping, you'll get a lot more noise if those U-bolts aren't tight.
The U-bolts, I regard that as a service item when you're on a trip, so not every day, but certainly every week if the trip's rough. You just climb underneath with a big power bar, 126 Newton meters, which is about, I don't carry a torque wrench in my toolkit.
92.9 foot-pounds, or 92.9 foot-pounds, or 1,115 inch-pounds. 126 Newton meters.
You can put paint on them, but it's not so much, you know, paint to see if they're undoing, but undoing isn't really the issue. The steel actually stretches over time, so you just got to make sure that they're good and tight, and an ordinary socket won't fit. You need a long socket, an extended socket.
Same with cylinder head bolts, things like that. You go too tight, you can snap them. Too loose, they'll come apart. On the front, there's not really much to service, but there are visual keys to know when you've got an issue or when there's something not quite right. In a lot of older springs, because these are powder coated, it's not paint, it's powder coat. After you've done a lot of duty cycles with the spring, you can get cracking through the powder coat. Once you get a crack or a massive chip out of it, you can get rust forming underneath the powder coat, which will cause it all to flake off. ARB have gone to a lot of effort to try to prevent this. So what ARB do, one, not only does it help the powder coat adhere to the surface, it also helps with the life of the spring itself, is they shot paint it. So what that means is when, after manufacturing, after it's gone through the process of making the spring, they fire little ball bearings at it, and what it does is it relieves the surface tension across the whole surface of the spring. The same thing you can do with con rods in an engine. It releases that surface tension, stops it bending, stops it cracking, and it stops all the surface tension across the whole spring itself. A lot of cheaper springs on the market don't have that included, so what you'll find over time is you'll get droop, you'll get them sagging essentially.
So you're saying without the shot peening treatment, it'll last longer. In other words, it'll take far more duty cycles before it starts weakening and sagging.
Yeah,
is that what you're saying? Okay.
Correct.
And the bump stops, how are my bump stops looking?
Yeah.
They're looking all right.
Factory.
Yeah, they're factory.
Yeah.
But they...
no, they look good.
They look fine.
Yeah.
They're in the middle, they're down the centre, they aren't cracking, and they're there. They're there, and they're not about to come out.
In terms of vehicles like this, or people that go away for the weekend or touring trips, a factory bump stop's perfectly fine. If you're going bigger than 2 inches, I would suggest putting a bigger bump stop in, because you're going to hit coil bind before
hitting the rubber. You're going to hit, yes.
So you're going to have metal on metal contact before you even touch that bump stop.
So what James has just said is basically the spring is fully compressed before the axle hits the bump stop. So you need to make a bigger bump stop with very large lifts.
If you have a cracked caster bush, or you don't have caster correction in your vehicle, at higher speeds it will act like a boat. It will be very sway, it will move around the road quite a lot. You can also get terrible wheel shake if you have cracked or broken caster bushes, which is quite dangerous at higher speeds. Panhard rod bushes, so these arms, you can get either the bolt will come loose or your bushes will wear out, especially on this end because this is doing a lot of work. This will stop the diff from going side to side and it holds it square into the middle of the car. That's why you can get adjustable ones. It's pretty good. There's no cracking or anything involved in that. Steering dampener, whether it's factory or not. Essentially it's a shock absorber. These very rarely wear out because they're not doing that much work. In terms of wheel shake, if that's in place or it does go bad, it will cause wheel shake because your whole diff will be moving, but I'd be more concerned of these.